It's Mr. Crandall coming to you now to help you with math boxes for lesson 8-3. This is in your math journal, page 260. If you need to find that, just press pause for a moment. Question 1 is a measurement question. It says, measure this line segment to the nearest quarter inch, 1/4 of an inch. And then it says to draw a line segment that is 1 inch shorter. Now, I don't think I really have a ruler here that I can use to measure on my computer screen because I think it would be wrong. But here's what I want to tell you. I have a little song about measuring. Start at the left end every time. There might be a 0 or a line. Don't start off at the 1 or you'll measure it too long. Don't start off in the middle or you'll measure it plain wrong. So start at the left end every time. There might be a 0 or a line. Remember and you'll be just fine. All right, so what I'm saying when I sing that song is that when you're using a ruler, you want to start off at the far left end, and then if there's a little line with a 0, start there. If there's not, just start at the left end. Don't start with the 1, don't start off in the middle, just start at the left end. So what I would do is I would place the left end of my ruler right here, and then I would measure how long this is to the nearest quarter inch. Your ruler on the inches side probably is split up into eighths even. So there's a longer line in the middle, that's the half an inch line, and then to either side of that there's going to be a slightly longer line. Those will be for your quarter inches or fourths of an inches, and then in between that there might even be smaller pieces. So if I were to lay a ruler down, I would find that this is about 2 1/4 inches long, this line. 2 1/4 inches. And then the next part would be for you to draw a line segment that is 1 inch shorter. Well, what would be 1 inch less than 2 1/4 inches? That's right, 1 1/4 inches. So you would use your ruler to measure 1 1/4 inches. Okay, the rest of these should be considerably easier to do with me leading you via the computer. Okay, question 2. Something equals 8 times 2. Something equals 8 times 2. Well, what is 8 times 2? I could skip count by 2s if I wanted, or I maybe just have this one memorized, but 2, 4, 6, 8, 10, 12, 14, 16. That's 8 times 2 is 16. Not 61, 16. Okay, so then 80 times 2 is going to be really similar to that. 80 is 10 times larger than 8, so then our product will be 10 times larger. It will be 160. Okay, so 80 times 2 would be 160. So for this next one, 9 times 3 equals 27. And then so I see one of my factors got larger by 10. We're extending these facts. The 3 got larger by 10, so that means my product will get larger by 10. To make it bigger by 10, I just add a 0 at the end, and that would be 270. 270. Box number 3 asks me to fill in the missing numbers on this number line. This number line goes from 0, and then there's a jump, and then it goes to 1, then another jump, and then it goes to 2. And down here it's got it labeled with fractions for me. 0 halves, something 2 halves. So in between 0 halves and 2 halves would be the fraction 1 half. 1 half. So 0 halves, 1 half, 2 halves, and then 3 halves, and then 4 halves. Cool. 4 halves is the same thing as 2 wholes. 3 halves is the same thing as 1 and 1 half. Whew, made it. Okay, this one says write 2 different fractions that name the shaded areas of both rectangles, right? 2 different fractions that name the shaded areas of both rectangles. Okay, so let's just take a look at this one here. If I were to pretend that there were no extra lines, I could see that like the top half and the bottom half are the same size. The bottom half is shaded. So I could say that 1 half of this rectangle is shaded. And this one here it's the same amount because it's 1, 2, 3 pieces, 1, 2, 3. But this one really, to me, doesn't obviously look like 1/2. So let's talk about this one in terms of how many pieces there are shaded. There's 1, 2, 3 pieces shaded. No. 3 pieces shaded. And how many pieces are there in all? That will be on my denominator. There's 1, 2, 3, 4, 5, 6. So 3/6 are shaded. 3/6 and 1/2 are equivalent fractions. They really are. Number 5, partition the rectangle below into sixths and shade it in a different way to match the fractions you wrote in problem 4. All right, so problem 4, we said 1/2, 3/6. So we need to split this into sixths. Ooh, wait a second. I just noticed another tool that I could use. Hang on. Let me erase that if it will let me. Nope. Oh, wait. Actually, it was letting me. Let's try it again. Let's get a big eraser here. Cool. All right, and now I'm going to do this instead. So I'm going to split this into 6 equal pieces. So I'm going to split it in half this way. And I'll go here and here. It's not perfect, but it's fine. And now I'm going to shade 3/6. You can do this any way you want except shading the 3 on the bottom because that would match this. And don't do 1, 2, 3 because that would match this one. But shade in 3 out of 6 pieces another way. And let me switch it from eraser to pen. And here we go. We'll see how this goes. 3/6. 1. Hey. And I'll do this one, 2. And I'll do this one, 3. But Mr. Crandall, I did different ones. That's okay. Just make sure you shade 3 of them because that would show 3/6. All right, and that is your math boxes 8-3. Thanks a lot. Have a great day.